Haripude. Then you should identify this is an ionic compound, right? You should identify this as an ionic compound. You should identify this as an ionic compound, and it is twice of formation enthalpy, right? It is twice of formation enthalpy. You can do this question by just using a thermochemical cycle, right? You can do this question by just using a thermochemical cycle, but I am doing this question by using a Born-Haber cycle, right? By using a Born-Haber cycle, right? Because it's good for your better understanding about Born-Haber cycle, right? It is Born-Haber cycle, right? About Born-Haber cycle. Actually, specifically mentioning, they have not asked a Born-Haber cycle for 15 years, right? In advanced level chemistry paper, they have not asked Born-Haber cycle specifically. I mean, in an essay question for 15 years. 2008 is the last year. I mean, 13 years, right? 2008 is the last year they have asked a Born-Haber cycle, right? A Born-Haber cycle, right? Anyway, so I'll do the question as Born-Haber cycle, right? I construct a Born-Haber cycle. 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 Okay. Calculate the enthalpy change for the reaction magnesium solid plus oxygen 2 MgO solid. You should understand. Here you have enthalpy of formation. It is twice of enthalpy of formation, right? It is twice of enthalpy of formation. So what are the informations you are given? Bond dissociation enthalpy of oxygen. So what is bond dissociation enthalpy of oxygen? What is bond dissociation enthalpy of oxygen? Bond dissociation enthalpy of oxygen. What is bond dissociation enthalpy of oxygen? What is bond dissociation enthalpy of oxygen? In oxygen molecule, you have OO double bond. You break it by producing two gaseous state atoms. That is what you called as bond dissociation enthalpy, right? That is what you called as bond dissociation enthalpy. Delta H naught D, right? Delta H naught D bond dissociation enthalpy. Delta H naught D bond dissociation enthalpy. Delta H naught D bond dissociation enthalpy, right? The value is 498 kilojoules per mole. 498 kilojoules per mole, right? Then first electron affinity of oxygen. I have mentioned in the earlier question I have mentioned in the earlier question, according to new syllabus, we consider this as enthalpy of electron gained, right? Electron gain enthalpy, right? We consider this as electron gain enthalpy according to the new syllabus, right? According to the new syllabus, we consider this as electron gain enthalpy, right? Electron gain enthalpy, because definitions for the electron affinity, and actually definition for the electron affinity is changed from a UPSC, right, committee, right. Definition for electron affinity is changed from a UPSC committee. So that's the reason. So now the definition, delta H naught T equal 498 kilojoules per mole, that is bond dissociation enthalpy. Electron affinity, I consider that as electron gain energy. Electron gain energy minus 149. Minus 149. So delta H naught electron gain energy is equal minus 100 minus 149 minus 149 kilojoules per mole. 149 kilojoules per mole. Then second electron affinity means second electron gain enthalpy. Second electron gain enthalpy. In second electron gain enthalpy, you take another electron. You take another electron by producing minus 2 anion, right? You take another electron by producing minus 2 anion, that is delta, this is electron gain enthalpy 1, and this is delta H naught electron gain enthalpy 2, right? Electron gain enthalpy 2, delta H naught electron gain enthalpy 1, that means first electron gain and the second electron is gain. Once you gain one electron, you get minus 1 charge, and in the second electron you get minus 2 charge, right? Minus 1 and minus 2. So its value is 798. Its value is 798 kilojoules per mole. Okay, kilojoules per mole. That is a second electron affinity of oxygen, which means second electron gain energy, right? Second electron gain energy. Second electron gain energy. So when you are doing past paper questions, right? When you are doing past paper questions, you have two changes under new syllabus. The first one is lattice enthalpy. In old syllabus, lattice enthalpy is a negative value, but in the new syllabus it is a positive value, right? Because they have reversed the definition, right? They have reversed the definition. Then the second one is electron affinity. Again, they have reversed the definition for the electron affinity, right? They have reversed the definition for the electron affinity. Now, if they have mentioned in an enthalpy question electron affinity, right? I mean, in old questions, right? In old question, if they have mentioned that electron affinity of this element is this scalar, you just consider that as electron gain energy of this element is this, right? So when you are doing past paper questions, right, remember that electron affinity values they have given, right, electron affinity values they have given in past paper questions are exactly equal to the electron gain energy values, right, to the electron gain energy values. Right. Then enthalpy of sublimation, right, enthalpy of sublimation, enthalpy of sublimation of magnesium, right, enthalpy of sublimation of magnesium, Mg solid is converted into magnesium gas. This is what you called as enthalpy of sublimation. This is what you called as enthalpy of sublimation. This is what you called as enthalpy of sublimation. Enthalpy of sublimation 148 kilojoules per mole. 148 kilojoules per mole. 148 kilojoules per mole, right? Okay. පොතේ මේ වෙනකන් ලියා ගන්න අපි enthalpy of sublimation කියන එක define කරගන්න ඕන, right? enthalpy of sublimation කියන එක define කරගන්න ඕන. මේ ලියා ගන්න. definition එක enthalpy of sublimation. Enthalpy of sublimation. It is the enthalpy change measured at standard temperature and pressure. It is the enthalpy change measured. It is the enthalpy change measured at standard temperature and pressure. It is the enthalpy change measured at standard temperature and pressure. It is the enthalpy change measured at standard temperature and pressure. When 1 mole of a solid compound, when 1 mole of a solid compound is converted, 1 mole of a solid compound is converted into 1 mole of its gaseous state, compound or element. පුතේ definition එකේ චූටි වෙනසක් කරගන්න මෙන්න මේ විදිහට බලන්න. It is the enthalpy change measured වෙනස් වුන්නේ නැහැ. එතන වෙනස් වුන්නේ නැහැ. It is the enthalpy change measured at constant temperature and pressure. වෙනස් වුන්නේ නැහැ. At constant temperature and pressure. වෙනස් වුන්නේ නැහැ. At constant temperature and pressure වෙනස් වුන්නේ නැහැ. When 1 mole of a solid compound එතෙන්ට කාකපාතයක් දාලා ලියා ගන්න. 1 mole of solid compound or an element. 1 mole of solid compound or an element. 1 mole of solid compound or an element. 1 mole of a solid compound or an element. One mole of solid compound or an element. One mole of a solid compound or an element is converted into a gaseous state, compound or an element. Compound or an element. Into a gaseous state, compound or an element. Right, පැහැදිලිද? අර පුතේ enthalpy of sublimation, delta H naught sublimation of magnesium, delta H naught sublimation of magnesium is that is 1 mole of magnesium solid, 1 mole of magnesium solid is converted into 1 mole of magnesium gas. 1 mole of magnesium solid, 1 mole of magnesium solid is converted into 1 mole of magnesium gas. That is what you call it as enthalpy of sublimation. Standard enthalpy of sublimation. It is a standard enthalpy of sublimation. The value is 148 kilojoules per mole. පැහැදිලිද කියන දේ? Right. Then first electron affinity, right? Second electron affinity, right? Enthalpy of sublimation, first ionization energy of magnesium. So what is first ionization energy of magnesium? Gaseous state magnesium atom, right? 1 mole of gaseous state, 1 mole of gaseous state magnesium, 1 mole of gaseous state magnesium atoms, 1 mole of gaseous state magnesium atoms are converted into 1 mole of gaseous state magnesium ions, right? Into 1 mole of gaseous state unipositively charged, right? 1 mole of gaseous state unipositively charged. 1 mole of gaseous state unipositively charged means you have one charge. 1 mole of gaseous state unipositively charged magnesium atoms. Then this process 1 mole of electrons are released, right? In this process 1 mole of electrons are released. So your enthalpy delta H naught ionization, it is first ionization energy of magnesium. It is first ionization energy of magnesium. First ionization energy of magnesium 738 kilojoules per mole. 738 kilojoules per mole. 738 kilojoules per mole, right? 738 kilojoules per mole. First ionization energy of magnesium. Then second ionization energy of magnesium. So gaseous state magnesium 2 plus, gaseous state magnesium plus one cation, gaseous state magnesium plus 1 cation is converted into gaseous state plus 2 cation and 1 mole of electron, right? That is the second ionization energy. Of magnesium. What is it? 1 mole of gaseous state unipositively charged cations. 1 mole of gaseous state unipositively charged cations are converted into 1 mole of gaseous state bipositively charged. Bi means 2. Bi, right? Bipositively charged. Natham dipositively charged, right? Dipositively charged cations. That is what we call as second ionization energy. Delta H naught. Second ionization energy. Delta H naught I2, right? Delta H naught I2. delta H naught I2. Delta H naught I2. Okay, then that is the second ionization energy, right? Second ionization energy of magnesium. That is the second ionization energy of magnesium, right? Second ionization energy of magnesium. Then lattice energy of magnesium oxide. So what is the definition for the lattice energy of magnesium oxide? 1 mole of ionic compound present in standard temperature and pressure. 1 mole of ionic compound present in standard temperature and pressure. 1 mole of ionic compound present in standard temperature and pressure is converted into gaseous state. Its constituent ions. Here you have magnesium oxide solid. Here you have magnesium oxide solid, MgO solid. So 1 mole of ionic compound, 1 mole of ionic compound present in standard temperature and pressure. 1 mole of ionic compound present in standard temperature and pressure is converted into its gaseous state. Constituent ions magnesium and oxygen. Valency of magnesium is +2, so magnesium 2 plus. Valency of oxygen is -2, that is O2 minus ion. So this is what you called as enthalpy of lattice. Enthalpy of lattice minus 3000 නෙමෙයි අන්න එතන තමයි point එක. In old syllabus, right, in old syllabus the definition for the lattice enthalpy is reversed, right? Then old syllabus එකේ you have negative value for lattice enthalpy, but in new syllabus the definition is reversed. Therefore you get exactly the same value but opposite sign, right? According to the new syllabus, the value is exactly equal for the lattice enthalpy, but the sign is opposite, right? Right? So it is minus. So values. I1 is 738. Second ionization energy 1451. Second ionization energy 1451. Then lattice enthalpy 3791. 3791. Okay, so these are the enthalpy values associated with the Born-Haber cycle of magnesium oxide, right? These are the enthalpy values associated with the Born-Haber cycle, right? With the Born-Haber cycle of magnesium oxide, right? These are the enthalpy values are associated with the Bohr-Haber cycle of magnesium oxide, right? Bohr-Haber cycle of magnesium oxide, right? Right. පුතේ ලියා ගන්න මේ ටික. Right. ඊට පස්සේ පුතේ මෙහෙම ලියා ගන්න. To calculate either lattice enthalpy, 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 or to calculate either lattice enthalpy or to calculate either lattice enthalpy or enthalpy of formation, to calculate a lattice enthalpy, to calculate either lattice enthalpy or the enthalpy of formation of an ionic compound, to calculate either lattice enthalpy or enthalpy of formation of an ionic compound, a Born-Haber cycle can be constructed. A Born-Haber cycle can be constructed. Can be constructed. Hari. Pude api Born-Haber cycle ekak gamu. What do you mean by Born-Haber cycle? Enthalpy level diagram. Enthalpy level diagram. It is enthalpy level diagram. It is enthalpy level diagram of an ionic compound. It is enthalpy level diagram of an ionic compound, right? It is enthalpy level diagram of an ionic compound. So here you have enthalpy kilojoules. Enthalpy kilojoules, right? That is the axis, energy axis or the enthalpy axis. Here you have enthalpy kilojoules, right? So, first of all, you should write, right? You should write the enthalpy of lattice, right? You should mention the enthalpy of a lattice, right? Enthalpy of lattice when you construct a thermochemical cycle, right? When you construct a thermochemical cycle, you should mention the enthalpy of lattice, right? You should mention the enthalpy of lattice. So what is the enthalpy of lattice? I'll take somewhere here to mention. I'll take somewhere here to mention the position of MgO, right? To mention the position of MgO, which means the enthalpy of MgO. MgO solid. MgO solid, right? So that is the position. So always take a much lower value, right? Much lower value in enthalpy, right? Right? You get always use a much lower value in enthalpy to mention the level of stable ionic compound, right? Level of stable ionic compound, MgO solid. MgO solid. Okay. Then enthalpy of lattice means you convert stable ionic compound into its gaseous state constituent ions, into its gaseous state ions, to convert into its gaseous state ions. To convert into its gaseous state ions. To convert into its gaseous state ions. Magnesium 2 plus gas plus O2 minus gas. That is the lattice enthalpy, right? That is the lattice enthalpy, right? And just I'll write here the Balanced chemical equation you should calculate, that is magnesium solid, 2 magnesium solid with oxygen gas, you get MgO solid, right, MgO solid. Right, MgO solid. Right, I just mentioned to get an idea. So here you can understand, you have 2 moles of MgO solid. You can understand you have 2 moles of MgO solid. 2 moles of MgO solid. So you have 2 moles of MgO solid, right? You should mention 2 moles of MgO solid, 2 moles of MgO solid, and 2 moles of Mg2 plus, 2 moles of O2 minus. Okay, because to produce 1 mole of MgO, you need 1 mole of Mg2 plus and 1 mole of O2 minus. To produce 1 mole of MgO, you need 1 mole of Mg2 plus and 1 mole of O2 minus. 1 mole of Mg2 plus and 1 mole of O2 minus. To produce 2 moles of MgO, you need 2 moles of Mg2 plus and 2 moles of O2 minus. Right. So, okay. Right. Hari. Pude may step එක අපි ලියාගමු. මේ step එක ලියාගමු. And wait. The enthalpy value is 3791. The enthalpy value is 3000. Yes. The enthalpy value is delta H naught lattice, that is equal 3791 kilojoules per mole, and that is for 1 mole of MgO, right? That is for 1 mole of MgO. That is for 1 mole of MgO. That is for 1 mole of MgO. So this should be multiplied by 2. 2 moles of delta H naught L. 2 moles of this, right? Twice of that, right? Again, twice of delta H naught lattice, because lattice enthalpy is defined for 1 mole of reactant, right? It is defined for 1 mole of ionic compound. It is defined for 1 mole of ionic compound. Here 2 mole of ionic compound is converted to its constituent ions. Its constituent ions. So twice of delta H naught lattice means twice of this value, right? Right. පුතේ මේ step එක අපි mark කරගමු. diagram එකත් එක්ක. enthalpy level diagram, right, for an ionic compound is the Born-Haber cycle. Enthalpy level diagram for an ionic compound is enthalpy level diagram of an ionic compound is the Born-Haber cycle, right? It is the Born-Haber cycle. Enthalpy level diagram of an ionic compound is the Born-Haber cycle. Haribudai. Then I'll go backward. You should produce magnesium 2 plus and you should produce O2 minuses, right? O2 minuses. Always I'll take the anion, right? I'll select the anion. So I'll select O2 minus, right? O2 minus. So that O2 minus is common. That O2 minus is common with the second electron gain energy, right? It is common with the second electron gain energy. I'll give numbers. First, second, third, fourth, fifth one, sixth one, seventh. So O2 minus is common with the third equation, right? O2 minus is common with the third equation. That is second electron gain energy, right? That is second electron gain energy. So to produce O2 minus, you need O minus and 1 electron. To produce O2 minus, you need O minus and 1 electron. To produce O2 minus, you need what? You need to produce O2 minus, you need to produce O2 minus, you need O minus O minus with 1 electron. O minus with 1 electron, you get O2 minus, right? O minus with 1 electron, you get O2 minus. Why did I mark the enthalpy level, that enthalpy level at this position, which is above to this? Because third equation, second electron gain energy, that is third equation. The second electron gain energy is a positive value, so I am wrong, right? It is a positive value and it is endothermic. It is a positive value and it is endothermic, so I am wrong. Endothermic. What do you mean by a positive value? A particular species absorb energy and a particular species absorb energy and the energy is increased. A particular energy absorb in a particular species absorb energy and increase its energy, right? And increase its energy into a higher value. That is what you call as endothermic reaction. That is what you call as endothermic reaction. A particular species absorb energy, and the energy of the species is increased. The energy of the species is increased. So it is an endothermic process. It is an endothermic process. Second electron gain energy. Second electron gain energy is an endothermic process. Second electron gain energy is an endothermic process. So energy of a particular species has increased. එහෙම increase වෙලා තමයි මේ වගේ position එකකට ආවිල්ලා තියෙන්නේ, right? It increased, right? Energy is increased. So it is an endothermic process. Energy has increased, right? Energy has increased. It is an endothermic process. Energy has increased. It is an endothermic process. Energy has increased. Okay. So O minus in gaseous state accept 1 mole of electron. O minus in gaseous state accept 1 mole of electron by producing 1 mole of O2 minus. By producing 1 mole of O2 minus. But here you should produce 2 moles of O2 minus. So you need 2 moles of O2 minus, 2 moles of O minus and 2 moles of electrons, 2 moles of O minus, 2 moles of O minus and 2 moles of electrons, 2 moles of electrons, 2 moles of electrons, and the energy that is enthalpy delta H naught electron gained, second one, right? Electron gain energy, second one, equal here third equation 798 kilojoules per mole, 798 kilojoules per mole, 798 kilojoules per mole, but twice of that, right? Twice of that, and twice of that. Okay, twice of that, because it is defined for 1 mole of O minus, right? The third equation, it is defined for 1 mole of O minus. It is defined for 1 mole of O minus. Okay, it is defined for 1 mole of O minus, right? Sorry, right? පුතේ ඒ step එක mention කරගන්න. ඒ step එක mention කරගන්න. හරි. පුතේ next step එකට අපි ගියොත් what is it? Next step එකට අපි ගියොත් so here still you have Mg2 plus gas, right? Mg2 plus gas, it has to be mentioned, right? It has to be mentioned. Mg2 plus gas, it has to be mentioned. because we are not changing it. We are not changing it, right? Each and every step, right? It's a new point. Each and every step, right? Each and every level of enthalpy level diagram has to be a balanced chemical equation. It's like balanced chemical equation. 2 Mg2 plus has to be here to balance this, right? 2 MgO and 2 Mg2 plus gas, 2 O2 minus, it is balanced. And this step 2 Mg2 plus, it has to be 2 Mg2 plus here, right? It has to be 2 Mg2 plus here. So 2 Mg2 plus, then 2 Mg2 plus balance, 2 O minus 2 electrons, right? 2 electrons, it is balanced, right? Charge balance again, right? Charge balance, right? That is what you call as, right? So each and every step has to be balanced. So each and every step has to be balanced, right? Each and every steps, each and every step has to be balanced. Each and every steps has to be balanced. Each and every steps has to be balanced. Okay, right? A level like a complete karagan hoda. A level like complete karagan. Right. Hari bude ilana api amu 2 Mg2 plus. Right. Then what is the next one? What is the next one? Here O minus, right? O minus can be produced, okay? O minus can be produced. O minus can be produced, that is, right? O minus can be produced from the second equation, right? O minus can be produced from the second equation. O minus can be produced from the second equation, that is first electron gain energy of oxygen gas, right? First electron gain energy of O gas. First electron gain energy of O gas. First electron gain energy. So first electron gain energy of O gas. First electron gain energy of O gas, what is it? it's a minus value, right? It's a minus value, minus 149. First electron gain energy, it is minus 149. So it is an exothermic process. Okay, it is an exothermic process. So I'll take this kind of enthalpy level, right? I'll take this kind of enthalpy level and I'll explain it later, right? I'll explain it later. Okay, here what is it? O minuses, second equation, O minuses can be produced from O gas and 1 electron. Okay, O minuses can be produced from O gas and 1 electron, right? O gas and 1 electron. O gas with 1 electron, you get O minus, right? O gas with 1 electron, O gas with 1 electron, O gas with 1 electron, you get O minus, right? O gas with 1 electron, you get O minus. Yes, O gas with 1 electron, O gas with 1 electron, you get O minus. Okay, O gas with 1 electron, you get O minus. But here you have 2 O minuses, right? Here you have 2 O minuses. So you need 2 moles of O gas, right? You need 2 moles of O gas because O gas, 2 moles of O gas. Here you have 2 moles of O gas. Here you have 2 moles of O gas. 2 moles of O gas converted into 2 moles of O minuses. 2 moles of O gas is converted into 2 moles of O minuses. 2 moles of O minuses. You need, right, 1 mole of O minus is produced from 1 mole of O gas and 1 mole of electrons. Then 2 moles of O minuses is produced from 2 moles of O gas and 2 moles of electrons. 2 moles of electrons. Right. But I have mentioned that each and every step, right? Each and every step of a Bonhoeffer cycle and thermochemical cycle has to be balanced. It has to be a balanced chemical equation. Each and every steps has to be balanced. You need 2 electrons to produce 2 O minuses, right? You need 2 electrons to produce 2 O minuses, and you have 2 electrons here, right? You have 2 electrons here. 2 plus 2, it has to be 4 electrons. It has to be 4 electrons. electrons. Right? Right. බලන්න පුතේ ආපහු. What is it? To produce O minuses, second balance chemical equation, right? Second balance chemical equation to produce O minuses. Second balance chemical equation to produce O minuses, right? To produce O minuses. To produce O minuses. To produce O minuses. To produce O minuses, you need O gas and electron, right? You need O gas. To produce O minus, you need O gas and electron. O gas and electron. But to produce 2 moles of O minuses, to produce 2 moles of O minuses, you need 2 O gas and 2 electrons. 2 O gas and 2 electrons. But when this conversion is taken place, you have 2 more electrons. You have 2 more electrons, right? You have 2 more electrons. That 2 more electrons has to be balanced with this. For this conversion, right? For this conversion, 2 moles of oxygen gas with 2 moles of electrons, you get 2 O minuses. For that conversion, you need 2 electrons. Other than that, still you have 2 more electrons in products. Still you have 2 more electrons in products. To get a balanced chemical equation, you need 4 electrons, right? Because 2 plus 2, 2 electrons for the conversion, and you have 2 more electrons in product side, right? 2 electrons for the conversion, and you have 2 more electrons in the product side. So altogether 2 plus 2, you need 4 electrons. You need 4 electrons in this step. And we did nothing for magnesium 2 plus, but it has to be there to obtain a balanced chemical equation. Okay? To obtain a balanced chemical equation, right? Right? Okay. Then, what about enthalpy values? Second equation, minus 149 delta H naught, electron gained, first electron gain, right? First electron gain enthalpy, and its value is minus 149 kilojoules per mole, but that value for 1 mole of O minuses, so twice of that and twice of this. twice of this. පැහැදිලිද කියන දේ? right. පුතේ ඒ ස්ටෙප් එකත් කම්ප්ලීට් කරගන්න. හරි පුතේ බලමු. Now why the enthalpy level is in between this and this. Why enthalpy value is in between this and this? Because what is the energy difference here? That is 798 kilojoules per mole, twice of that. Right? Energy difference here is 798 kilojoules per mole and twice of that. The difference is 1500. Okay? 1600, right? 798 can it's like 800. 800 into 2 kilo can 1600. So this difference is 1600. And what is this difference? It is 149. It is 149 twice of that, right? Twice of that. So that difference 150 into 2 means what is it? 150 into 2 means what is it? That is 300. So this difference is 300 and this difference is 1500. So definitely this has to be in between these two enthalpy levels, right? These two enthalpy levels, in between two enthalpy levels, and oya case method 300, method 1500, right? Method 1500, but it doesn't matter. In between all yandona, somewhere here liwana, right? Somewhere here, මෙයාගේ level එක somewhere here liwana, අන්න වැරදි. Okay. somewhere here, because it's a rough sketch, somewhere here it is greater than 1500, 300 is not greater than 1500, okay. 300 is not greater than 1500, but that in between this energy level and this, because it is 300, okay, it is 300, it is in between these two, it is 300, right, it is 300, okay, it is 300. So that's why I took the enthalpy level somewhere here, right. So when you have -2, okay, when you have -2 ion, okay, or -3 ion, okay, when you have -2 ion or -3 ion, you have this kind of issue, right. එහෙනම් -2 ion එකක් තිබ්බොත් කල්පනාවෙන් වැඩේ කරන්න, right, කල්පනාවෙන් වැඩේ කරන්න, you have this issue, right. මේක වරද්දන්න එපා. somewhere here මේ level එක තිබ්බොත් වැරදි. පැහැදිලිද කියන දේ? right. right. හරි පුතේ බලන්න. The next one. Now you have gaseous state oxygen, 4 electrons and magnesium 2 plus. Then I'll take magnesium 2 plus. Okay. So I'm going to produce magnesium 2 plus, 6th balance chemical equation. I'm going to produce magnesium 2 plus, I'm going to produce magnesium 2 plus, 6th balance chemical equation, okay, 6th balance chemical equation. So magnesium 2 plus, 2 of this, 2 of this, 6th balance chemical equation, production of magnesium 2 plus, that is what you call as second ionization energy. That is what you call as second ionization energy. So I'll take magnesium 2 plus, production of magnesium 2 plus, 6th balance chemical equation, 6th balance chemical equation, that is second ionization energy of magnesium. That is second ionization energy of magnesium. Production of magnesium 2 plus, that is second ionization energy of magnesium. Production of magnesium 2 plus, that is second ionization energy of magnesium, right. Production of magnesium 2 plus, that is second ionization energy of magnesium. Second ionization energy of magnesium. So it is plus 1451. It is plus 1451. So 1451 for 1 mole, right, for 1 mole, I'll take somewhere here and I'll explain later the difference, right. I'll take somewhere here and I'll explain the difference later. I mean enthalpy difference. Why I took this place Kineka, I'll explain later. I'll take somewhere here because it is an endothermic process. Endothermic process means the process absorb energy, the species in the process absorb energy, and the energy of the species will be increased. Species in the process absorb energy and the energy of the species will be increased. So it is an endothermic process. It is an endothermic process. The arrow mentioned increase in energy. right? Arrow mention increase in energy, right? So magnesium 2 plus is produced from Mg2 plus is produced from Mg plus gas, right? Mg2 plus is produced from Mg2 plus is produced from Mg plus gas. Mg2 plus is produced from Mg plus gas. Mg2 plus is produced from Mg plus gas. Alright, Mg plus gas. Mg plus gas, Mg plus gas is converted into Mg2 plus, but here you need 2 Mg, right? You need 2 Mg2 plus, so you need 2 Mg plus, right? You need 2 Mg plus, right? You need 2 Mg plus. But this process will produce only 4 electrons. Sorry, only 2 electrons. This conversion produce only 2 electrons. Why? Banda 6th balance chemical equation ega. 6th balance chemical equation ega. This process produce, right? 6th balance chemical equation ega balan, right? This process produce only 1 electron, only 2 electrons. Here 2 Mg2 plus, so I'll take 2 Mg2 plus. 2 Mg2 plus produce 2 Mg plus, I'll take 2 Mg plus. 2 Mg plus produce 2 Mg2 plus. 2 Mg plus produce 2 Mg2 plus. 2 Mg2 plus, right? 2 Mg plus produce 2 Mg2 plus. 2 Mg plus produce 2 Mg2 plus, and that process produce only 2 electrons. So this conversion produce only 2 electrons. This conversion produce only 2 electrons, but here you have 4 electrons. So you should have 2 more electrons to balance it. Okay, to balance that conversion you need 2 more electrons. You need 2 more electrons to balance it, right? You need 2 more electrons to balance it. And we did nothing for 2 oxygen atoms. We did nothing for 2 oxygen atoms. You write 2O gas here. We did nothing for 2 oxygen atoms. You write 2 oxygen gas here. 2 oxygen gas here. So our enthalpy is what? Our enthalpy is what? 1006th balance chemical equation, 1451 kilojoules per mole. 1451 kilojoules per mole, right? Delta H naught I2, delta H naught I2 means second ionization energy. Delta H naught I2 means second ionization energy. Delta H naught I2 second ionization energy. I2 means I capital Roman number 2, right? Delta H naught I2 means second ionization energy, and its value is 1451 plus 1451 and twice of that. Okay, twice of that. Okay, twice of that. Twice of that. Right, twice of that. 1451, twice of that. Okay, so that is the conversion. Hari, putih lihat kan? Lihat kan? Hari putih balana. Then what it is? What it is? So here for the conversion, again, what it is? You should produce 2 Mg2 plus. What is the balanced chemical equation? Sixth one. Sixth one is the balanced chemical equation. To produce Mg2 plus, you need Mg plus. To produce Mg2 plus, you need Mg plus. To produce Mg2 plus, you need Mg plus. 1 mole of Mg plus is converted into 1 mole of Mg2 plus. 1 mole of Mg plus is converted into 1 mole of Mg2 plus. 1 mole of Mg plus is converted into 1 mole of Mg2 plus. But you need 2 moles of Mg2 plus. You need 2 moles of Mg2 plus. To get 2 moles of Mg2 plus, you need 2 Mg plus. You need 2 Mg plus. But in the balanced chemical equation, you have 1 electron. To convert 1 Mg plus into 1 Mg2 plus, you need 1 electron. Sorry. To convert, in the conversion, right, sorry, in the conversion of Mg plus into Mg2 plus, 1 electron is released. In the conversion, balance sixth balanced chemical equation, 1 Mg plus convert into 1 Mg2 plus. 1 Mg plus is converted into 1 Mg2 plus by releasing 1 electron. 1 Mg plus is converted into 1 Mg2 plus. 1 Mg plus is converted into 1 Mg2 plus. 1 Mg plus is converted into 1 Mg2 plus by releasing 1 electron. But 2 Mg2 plus convert into 2 Mg2 plus by releasing 2 electrons. So 2 Mg2 plus convert into 2 Mg2 plus by releasing only 2 electrons. But here you have 4 electrons. For a balanced chemical equation, to balance the equation, you need 2 more electrons. That's why I have added 2 electrons here. To obtain a balanced chemical equation, you need 2 more electrons. To obtain a balanced chemical equation, you need 2 more electrons. Right? To produce for a balanced chemical equation, to balance the chemical equation, you need 2 more electrons. That's why I have added 2 electrons here. To balance this conversion, you need 2 more electrons, because here you have 4 electrons, but this conversion produces only 2 electrons. Here you have 4 electrons, and this conversion produces only 2 electrons. So you need 2 more electrons to balance this equation. That's why I have added 2 electrons here. And we did nothing for 2 oxygen. So to obtain a balanced chemical equation, 2 oxygen gas has to be added here. To obtain a balanced chemical equation, 2 oxygen gas has to be added here. Okay. right, இப்போ தெரியாத හරි හරි පුතේ බලන්න හරි then you should produce here you have 2 mg pluses you should produce mg pluses, right? You should produce mg pluses. So how can you produce mg plus? That is fifth balanced chemical equation. That is fifth balanced chemical equation. The fifth one, fifth balanced chemical equation. Fifth balanced chemical equation. The fifth one, right? Again, I didn't explain the position of this, right? Position of this. Why the enthalpy level at here? You can understand it is an endothermic, so arrow should show increase in energy, right? Arrow should show increase in energy, right? Arrow should show increase in energy because it is endothermic. If it is exothermic, arrow should show decrease in energy, okay? If it is an endothermic process, arrow should show increase in energy of species. increase in energy of species. If it is exothermic, arrow should show decrease in energy, right? Arrow should show decrease in energy. You can understand that. What about the position? This is 1451, alright? This is 1451 and twice of that 1451 and twice of that 1151 ke 1500 ke gato, that is 3000. That energy difference or the enthalpy difference is 1500. So it's 3000. But here this one, right? This one, right? This one just 300, okay? Because minus 149. Twice of that can be 300. So this is 300 means that 300 again in between this energy level and this energy level, because its difference is 3000. Its difference is 3000. Its difference is 3000. Its difference is 3000, right? Its difference is 3000, right? Then right, two O gases. So O gas, Mg pluses are produced according to fifth balance chemical equation. Mg pluses are produced according to fifth balance chemical equation. Mg pluses are produced according to fifth balance chemical equation, right? Mg pluses are produced according to fifth balance chemical equation. What is it? Fifth balance chemical equation. Mg pluses. To produce 1 Mg plus, you need to produce Mg plus gas, you need Mg gas, and it is also an endothermic conversion, right? It is also an endothermic conversion. So energy of species present as a reactant, energy of species present as reactants has to be increased, right? So Mg gas, okay, Mg gas is converted into Mg pluses. To produce 2 Mg pluses, you need 2 Mg gases. To produce 2 Mg pluses, you need 2 Mg gases. To produce 2 Mg pluses, you need 2 Mg pluses. To produce 2 Mg pluses, you need 2 Mg gases. And that conversion, right, 1 Mg gas produce 1 Mg plus and 1 electron. So 2 Mg gas produce 2 Mg plus and 2 electrons. 2 Mg gas produce 2 Mg pluses and 2 electrons. 2 Mg pluses and 2 electrons. 2 Mg gas produce 2 Mg pluses and 2 electrons. Okay. And we did nothing for O gas. We did nothing for O gas. We did nothing for O gas. You have O gas. Okay. And the enthalpy difference, delta H naught, what is it? First ionization energy first ionization energy I1 equal fifth conversion 738 kilojoules per mole, twice of that, twice of that, right, right. පුතේ conversion එකක් දාගන්න, ඒ conversion එකක් දාගන්න. ඒ conversion එකක් දාගන්න. හරි පුතේ බලන්න. Then you have two O gases, two Mg gases, right? Two O gases and two Mg gases. It doesn't matter. You can choose Mg gas or Mg gas or O gas. I'll take O gas. I'll take O gas. To produce O gases, it is first balance chemical equation, bond dissociation enthalpy of oxygen. Alright, bond dissociation enthalpy of OO double bond. Bond dissociation enthalpy of OO double bond. Right, bond dissociation enthalpy of oxygen. Bond dissociation enthalpy. Right, and it is an endothermic reaction. And it is an endothermic reaction 498 kilojoules per mole. It is an endothermic reaction 498 kilojoules per mole. 498 kilojoules per mole. 498 kilojoules per mole. Endothermic process. So O2 gas, right? O2 gas is converted into 2O gas. We did nothing for magnesium. Sorry. We did nothing for magnesium. We did nothing for magnesium. Delta H naught, delta H naught, delta H naught, delta H naught, what is it? Bond dissociation enthalpy 498. Kilojoules per mole. 498 kilojoules per mole, right? 498 kilojoules per mole, delta H naught D. So, but here you don't have twice. Here you don't have twice. Why? Because the enthalpy is defined for 1 mole of bonds. Enthalpy is defined for 1 mole of bonds, and in the definition, according to the definition, you get 2 moles of oxygen atoms, right? According to the definition, you get 2 moles of oxygen atom because only 1 mole of O2, only 1 mole of O2 will be converted into 2 moles of O gases, right? O gas atoms. When 1 mole of O2 gas is converted into 2 moles of O gas atoms, 1 mole of OO bonds are broken, right? 1 mole of OO bonds are broken because in O2 you have O double bond, and in a 1 molecule of oxygen you have 1 OO double bond. For 1 mole of OO double bonds, you need 1 mole of O2. When 1 mole of O2 is converted, or 1 mole of OO bonds are broken, when 1 mole of OO bonds are broken, you get 2 moles of O gases. You get 2 moles of O gases. Here you need 2 moles of O gases. For that, only 498 kilojoules per mole. Because that conversion results 2 moles of O gas. That conversion results 2 moles of O gas. You don't need to multiply. You don't need to multiply the bond dissociation enthalpy by 2, right? You don't need to multiply. Okay, right. Putih api kat lihat. Hari putih balam. Then I'll take Mg gas. I'll take Mg gas. I'll take Mg gas. So Mg gas produced from the fourth balanced chemical equation. Mg gas is produced from the fourth balanced chemical equation. It is produced from the fourth balanced chemical equation. Fourth balanced chemical equation. Then it is Mg gas is produced from Mg solid. It is produced from Mg solid. It is produced from Mg solid. It is produced from Mg solid. Right? It is produced from Mg solid. And 1 mole of Mg gas is produced. 1 mole of Mg gas is produced. 1 mole of Mg gas is produced. To produce 1 mole of Mg, 1 mole of Mg gas is produced, but here you need 2 moles of Mg gases. You need 2 moles of Mg gases. To produce 2 moles of Mg gases, you need 2 moles of Mg solid. You need 2 moles of Mg solid. 2 moles of Mg solid. Right? 2 moles of Mg solid. To produce 2 moles of Mg gases, you need 2 moles of Mg solids. To produce 2 moles of Mg gases, you need 2 moles of Mg solids. plus we did nothing, we did nothing for oxygen, so you have O2 gas. You have O2 gas. And the enthalpy delta H naught sublimation, delta H naught sublimation equal, for 1 mole of Mg gas it is 148, but here you have 2 moles of Mg gas. For 1 mole of Mg solid, to convert into 1 mole of Mg gas, to convert 1 mole of Mg solid to convert into 1 mole of Mg gas, you need that amount of energy. But for 2 moles of Mg solid to convert 2 moles of Mg gas, you need greater than that, twice of that, 148, twice of that, 148 kilojoules per mole, and twice of that, 148 kilojoules per mole and twice of that, okay, twice of that. So that's what happens. Now, right, put a conversion එකත් ලියාගන්න. एक conversion එකත් ලියාගන්න. एक conversion එකත් ලියාගන්න. හරි පුතේ. බලන්න. Now where we are, O2 gas and Mg solid, O2 gas and Mg solid, they are elements at standard temperature and pressure. They are elements at standard temperature and pressure. The enthalpy of elements at standard temperature and pressure, enthalpy value of elements at standard temperature and pressure, enthalpy value of elements at standard temperature and pressure is defined as 0, it is defined as 0, so it is 0 here. Today 0 එක mark කරගන්න, 0 එක mark කරගන්න, and the enthalpy level එක axis එකට touch කරන්න. enthalpy level එක axis එකට touch කරන්න, but වෙන කිසිම තැනක මේ enthalpy levels axis වලට touch කරන්න යන්න එපා. right, touch කරන්න යන්න එපා. මෙතන touch කරොත් mark ඒක value එක mark කරන්න ඕන. මෙතන touch කරලා 0 කියලා දාන්න, that's enough. right, that's enough. right, 0 එක mark කරගන්න, 0 එක mark කරගන්න. හරි පුතේ බලන්න. Then so we have used all the enthalpies we are given in the question. We have used all the enthalpies were given in the question. So what we should calculate? What we should calculate? We should calculate enthalpy change of this reaction. We should calculate enthalpy change of this reaction. 2 mg gas, 2 mg solid, 2 mg solid is converted, 2 mg solid is converted, 2 mg solid plus O2 gas, 2 mg solid plus O2 gas is converted into 2 mgO solid. That is converted into 2 mgO solid, right? It is converted into 2 mgO solid, right? 2 mgO solid, that's what you should calculate. That's what you should calculate, okay? That's what you should calculate. 2 mg solid plus O2 gas, 2 mgO solid. 2 mgO solid, right? That's what you should calculate. So here you have 2 mg solid, 2 mg solid, 1 O2 gas, 1 O2 gas is converted into 2 mgO solid. So your enthalpy change is someone like that, someone like this. Enthalpy change. This is your enthalpy of reaction, delta H naught reaction, right? This is what you should calculate. This is what you should calculate. හරි නේද? පුතේ එකත් මාක් කරගන්න. හරි පුතේ අපි Hess's law එක apply කරමු. Hess's law එක apply කරමු. එතකොට Hess's law එක apply කරන්න you need what? Hess's law එක apply කරන්න you need what? The starting point, right? The starting point and the end point, right? End point. So starting point එක ඔයා identify කරන්නේ කොහමද? Arrows වල, right? More than one arrow. Can it two arrowheads? Starting points of arrows, right? The starting side of arrow, right? Then arrow එකක් start කරන side එක මේකනේ. මේ තියෙන arrow එක මෙහෙමනේ වා ලියන්නේ. එහෙනම් මේ තමයි starting side of the arrow. මේක end එක. එහෙම නැත්නම් මේක arrow head එක. right? මේ තියෙන arrow එකේ back එක. එතකොට arrow එකේ back එක තියෙනවා, arrow එකේ head එක තියෙනවා, arrow backs, right? එතකොට arrow backs දෙකක්, right? arrow back එකේ දෙකක් right? arrow backs දෙකක් කොහෙද හම්බ වෙලා තියෙන්නේ? arrow backs දෙකක් කොහෙද හම්බ වෙලා තියෙන්නේ? එතන තමයි start එක. අපි කොහේ හරි තැනකින් පටන් අරගෙන බලමු arrow backs දෙකක් කොහේ හරි හම්බ වෙලා තියෙනවද කියලා. right මේ පැත්තනේ arrow back එක හම්බ වෙන්නේ. මේ පැත්තට. arrow back නෑ arrow back. මෙන්න පුතේ arrow backs දෙකක් හම්බ වෙලා තියෙනවට පේනවද? මෙන්න මෙතන arrow backs දෙකක් හම්බ වෙලා තියෙනවා. මේ බලන්න. මෙන්න මෙතන. මෙන්න මෙතන තමයි arrow backs දෙකක් හම්බ වෙලා තියෙන්නේ. right ඒ කියන්නේ arrow එකේ starting points දෙකක් හම්බ වෙලා තියෙන්නේ මෙන්න මෙතන. arrow backs දෙකක් ඒ කියන්නේ arrow එකේ starting points දෙකක් හම්බ වෙලා තියෙන්නේ මෙතන. එහෙනම් මෙයා start එක. this is your start. end එක කියන්නේ මොකද්ද? arrow heads එකතු වෙන්නේ කොතනද? ඒක end එක. දැන් බලන්න arrow heads කොහමද එකතු වෙන්නේ කියලා. arrow head එක back එකට, 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 arrow head එක head එකට, අන්න arrow head එක head එකට හම්බුණා කියන්නේ that is your end. okay this is your end. මෙන්න end එක. arrow head එක head එකට හම්බුණා කියන්නේ that is your end. එහෙනම් start එකේ ඉඳන් end එකට තියෙන roots දෙක අපි identify කරගමු. මෙන්න start එකේ ඉඳන් end එකට මෙන්න root එක. start එකේ ඉඳන් end එකට මෙන්න root එක. start එකේ ඉඳන් end එකට root එක. එතකොට start එකේ ඉඳන් end එකට root එක කියලා කියන්නේ ඒක මම ගන්නම් R2 කියලා. root number 2 R2 කියලා root number 2 and මේ පැත්තෙන් start එකේ ඉඳන් end එකට that is your root number 1 right root number 1 මම හැම වෙලේම root number 1 කියලා ගන්නෙ කවුද? අර calculate කරන්න right the one you are asked to calculate right අන්න එයා include වෙන root එක මම හැම වෙලේම root 1 කියලා ගන්නවා right දැන් මෙතනදී ඔයාට calculate කරන්න අහලා තියෙන්නේ මෙයාව ඒ නිසා එයා include root එක මම root 1 කියලා ගත්තා right එයා include වෙලා තියෙන root එක මම root 1 කියලා ගත්තා එයාව include වෙලා තියෙන root එක මම root 1 කියලා ගත්තා පැහැදිලිද කියලා දෙයි එහෙනම් root 1 එක identify කරා root 1 එක identify කරා this is your root 1 and this is your root 2 ඒ දෙක identify කරගන්න root 1 and root 2 identify කරගන්න ඕන ඔයාට Hess's law එක apply කරන්න root 1 and root 2 has to be identified to apply Hess's law හරි නේද පුතේ ඒ දෙක identify කරගන්න ඒක ලියා ගන්න හරි පුතේ. එතකොට දැන් මම හෙසස් ලෝ එක ඇප්ලයි කරනවා. 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 right හෙසස් ලෝ එක ඇප්ලයි කරනවා. so the first one root 1 එක මම ගන්නවා delta h naught reaction තමයි. you have delta h naught reaction to be calculated. You have delta h naught reaction Rxn to be calculated. Rxn to be calculated plus delta h naught reaction to be calculated. Delta h naught reaction to be calculated. Calculate the enthalpy change, right? Then so our root 1 again I know delta h naught reaction plus delta h naught lattice, twice of delta h naught lattice. That means 3000 according to Hess's law ke liyan ඕන, right? According to the Hess's law, according to the Hess's law, 5 marks, right? Hess's law 5 marks. So definitely according to the Hess's law කියන එක ලියන්න ඕන 5 marks. According to the Hess's law, according to the Hess's law 5 marks. According to the Hess's law, delta h naught reaction plus twice of twice of 3791 kilojoules per mole, right? That is equal to what? The other root. Summation of enthalpy changes of one root is equal to the summation of enthalpy changes of the other root. That is what you call as Hess's law. Okay. So here twice of 148, right? Twice of 148 plus 498 plus twice of 738 plus twice of 1451 plus twice of 1451 plus twice of 149, twice of minus 149 plus twice of minus 149 plus minus 149 plus twice of 798, twice of 798 The unit is kilojoules per mole. Right. Kilojoules per mole. Right. मुझे simplify करेगा. You get the answer. Minus 1112, you get the answer, minus 1112 kilojoules per mole. Right, that is the answer.